This is a train built for climbing mountains. A thrilling, chilling roller coaster through the Swiss Alps, with twists and turns that would derail most other trains. And some hair-raising natural hazards, too. The Glacier Express is a world-class Alpine ride, and I'm about to get a panoramic view.
Using unique technology on the locomotive and amazing engineering along the route, it climbs over 16,000 feet. That's almost 5 kilometers high through the magnificent Swiss Alps. It carries hundreds of thousands of people every year and is one of the most famous trains on Earth.
That's the majestic Matterhorn, the king of the Alps. And this is where my day begins, in the famous ski town of Zermatt, at the foot of the Matterhorn. This is a car-free town, just hikers and skiers, and a mighty train service.
And it's because of towns like this that the Glacier Express was built. People had been coming up here for ages during the summers for the invigorating mountain air. But when skiing became popular about 100 years ago, getting tourists here in the winter was incredibly difficult. The Glacier Express was the solution.
But first things first, the Glacier Express heads into a depot near the station for its daily morning maintenance check. Technical inspector Philibert Moser is a hard man to please, and no one's going anywhere until he says so.
De eerste taak mag u controle van onderbouw. Zahnräder, die Räder, die Achsen, die Verschraubungen, die hydraulischen Sachen, das kontrolliere ich alles an einem Tag.
A train that tackles steep mountains every day needs a secret weapon, and this is it, rack and pinion technology. The round cogwheel, or pinion, attached to the undercarriage of the locomotive, has teeth that slot into another set of teeth on a straight rack between the rails. On the steepest sections of the track, going up or down, the cogwheel will help to give the Glacier Express an amazing Alpine advantage: steel traction. Philibert eyeballs the rest of the undercarriage and notices that some brake pads need replacing.
Also, wenn ich Kontrolle mache, sehe ich optisch, wenn der Klotz abgenutzt ist, muss ich den auswechseln. Und in 5 Minuten ist so ein Bremsklotz gewechselt.
Once Philibert signs off on the brakes, cogwheel, and other components, they get a scrub down and go through a giant train wash. Shiny carriages and crystal clear windows will keep the tourists happy. Then it's hookup time. Carriages connect with the locomotive, and the Glacier Express rolls into the station for boarding.
Track 12, the train now arriving is the Glacier Express to Andermatt, Disentis Moster Kur, St. Moritz. Departure at...
Engineer Odilo Polinger is the guy who gets to sit in the cab up front.
I'm the driver here, and it's a really nice job.
Odilo has a special relationship with this train. He's known it all his life.
So when I was a little boy, my parents' house was near the track, and I saw every train who passed the line. So it was a boy dream to become an engine driver.
We're leaving in less than 5 minutes. Yolanda Alini, the train conductor, does her final check of all the carriages and uses light signals to tell the engine driver the train is good to go.
When we prepare the train in the morning, we have as well a lighting information for the driver. And now everything is working good.
The catering crew gets to work before the trains even left the station. Alexandra runs the Glacier Express's kitchen, and her staff will need to whip up a gourmet lunch for as many as 210 passengers, working in a galley that can sometimes feel more like a carnival ride.
You know, you don't have much space, so you have to keep the balance, you know, like you have to also get used to it, and yeah, it's very challenging, yeah.
The train's crew is all set to tackle another journey. Me, I've never been to Switzerland before, and I'm really stoked. I can't wait to find out more about the train's ingenious technology that makes it possible to conquer its Alpine route. Our journey sets off from here and follows a crooked line through the middle of the Swiss Alps, from west to east. But that's only half the story, because our 290-kilometer journey is also about going up and down. We'll travel up mountains 2,044 meters high and down into deep valleys, across 291 bridges and through 91 tunnels to arrive at our destination of St. Moritz.
Ladies and gentlemen, the Matterhorn-Gotthardbahn train crew welcomes you aboard the Zermatt shuttle from Zermatt.
The Glacier Express has left the station.
Ik hoop op een lokaal.
Ja, meneer, dat is richtig. Die omvaren het Fahrzeug.
Ja, dat is goed, merci.
Ja.
I find myself in the middle of an amazing mix of nationalities. There's something kind of Swiss about that. 250,000 passengers a year come from all over the world to take this ride.
We're New Zealanders, so we do mountains.
So where are you guys from?
From Bangkok, Thailand.
We're from Lucerne, Switzerland.
We're from Ottawa, Canada.
And this United Nations vibe is Alexandra's favorite part of the job.
I can meet new people, so it's very international, like also the beautiful landscape.
It's a view that never gets old for Alexandra and her team.
No, because sometimes you don't have any time to look outside.
Up front in the locomotive, and only minutes into this trip, the train is already in a steep descent. And Odilo is about to make his first use of what makes this train so unique, the cogwheel.
There is the start of the cogwheel. And we're in.
The Glacier Express is a model of Swiss quality and design. The locomotive has 2 cogwheels, along with 4 normal drive motors. That means it can switch back and forth between the cogwheels and its steel wheels, same as the ones on other trains. It's all electric, using overhead power lines to provide enough horsepower to pull 200 tons up a mountainside.
When we go down to Brig, the gradient changes, and when the gradient is bigger than 7%, we need the cogwheel. Otherwise, we slide down the mountain. So the cogwheel helps us to put the train down. So now we are on the cogwheel.
I'm up in the observation carriage, taking in the striking scenery. With the Matterhorn peak at our backs, so far, it's all downhill.
It's really steep, yeah.
Engineer Odilo heads the train down into the Rhone Valley and never takes his eyes off the track. His reflexes and the emergency brake are all that stand between a rock on the track and a potential train wreck. But soon, we'll be battling terrain that's derailed even the meanest mountain train. I'm into the first hour of my Alpine train ride through Switzerland on board the Glacier Express. Even though we're on a mountain railroad, it's been all downhill since Zermatt.
It's really steep, yeah.
We're losing about 1,000 meters in altitude in our first 90 minutes, on a track with a grade that would be unsafe for any normal train.
And after this we go down also 12.5%.
It will take us about 8 hours to cover these 290 kilometers, so I've got plenty of time to soak up the scenery. That's because even though the Glacier Express can travel up to 100 kilometers an hour, it rarely does. And with the cogwheel engaged, it can only go 40. No wonder it's called the slowest express train in the world. The cogwheel is what puts the Glacier Express in an exclusive niche market at the top end of the train manufacturing industry. This is the world-renowned Stadler Rail manufacturing plant in Bussnang, Switzerland. The carriages are custom built here. Stadler specializes in mountaineering trains, deploying the most high-tech science and quality engineering in the industry. Not that rack and pinion technology is new.
Technology of cogwheel railways is more than 100 years old. So at that time we had great engineers who invented those systems, which is still valid nowadays. Not all of the time.
Rolf Waldvogel is the team leader of the Bogies and Wheels department at Stadler Rail.
What has changed is a lot of materials are different now. They're stiffer, they're harder. So we have less wear on the parts, but the technique itself is the same.
In the bogie room at Stadler Rail, engineers make and maintain the bogies. A bogie is the truck or base of the train's carriages that houses the cogwheel and brakes, and Rolf is an expert on the cogwheel design.
Well, we are standing in front of a gearbox which drives a cogwheel train. We've got a mechanical gearbox which is driven by an electromotor of roughly 300 kilowatts, or in other words, some 450 horsepower, driving one axle. Or in other words, it's driving not only the axle or the wheels, it is also driving the cogwheel here.
Most trains are simply steel wheels on a steel track for the smoothest possible glide, sometimes called an adhesion locomotive. But that means they work best on a near flat surface, up to a 3% grade, or a slope of about 25 meters per kilometer.
For a flat railway line, which it would be about that, we have maybe 4% is like that, 6, 7%, and then roughly in this area we need the cogwheel.
The rack in a rack and pinion system is the fixed line of steel teeth running down the center of the train track between the two rails. When the turning cogwheel's teeth lock into the stationary rack's teeth, there's no more slipping and sliding, even on a slope with 12 or more degrees gradient.
Now we come to the end of the cogwheel. And I can drive faster.
We've made it down to the first low point on our route, 658 meters above sea level. This is the Rhone Valley. Coming up soon is Brig, a 13th century village that speaks mostly German. From here, we'll need to gain 1,400 meters in altitude.
So the next cogwheel will start shortly.
It's going to be an uphill battle. And once again, only the cogwheel makes it possible. I'm about to experience my first really steep climb. As the Glacier Express heads uphill, its locomotive is fighting gravity with 8 cars in tow.
That got 185 tons, the whole train together.
The heavier the load, the more energy it takes, and the more costly it gets. Which is why, under Rolf Waldvogel's direction,
Here we are standing in front of a roof for a lightweight car body.
the folks back at Stadler Rail in Busnang are perfecting ways of keeping the Glacier Express carriages as lightweight as possible.
You want to have a light train to go up there because consumption of energy. Rather, you choose a light train than one made from steel, which is really heavy. And we're using here aluminium alloy in order to reduce the weight. Now, some 98% of our car bodies we produce are made from this material.
We're slowly edging up into snow country.
Dag middenand, hier de vaarkaartenbieten. De BS s'il vous plaît, your ticket, please. Dank u vielmals. Carte is on top. Perfect.
Now this is starting to look like the classic Switzerland of my imagination. The Swiss Alps are a magnet for winter tourists. A top holiday destination ever since downhill skiing became a popular sport in the early 1900s. But getting here was a big challenge, until the Glacier Express got rolling on June 25th, 1930. Since then, it's transported passengers safely and in style. But sometimes, even Swiss engineering is no match for nature's fury.
Because there is a new track, there was a mountain slide on the other side, so the old track is away.
In 2014, another landslide derailed a Glacier Express train. 3 carriages plunged over the edge. 1 passenger died and 10 were injured. But the biggest danger in the Alps has always been at the higher altitudes, getting buried in snow. And we're about to enter the notorious avalanche zone, so dangerous that it kept the Glacier Express from risking winter service for its first 50 years. The mighty Glacier Express is edging up towards the highest point of its route through the Swiss Alps. We've regained the 1,000 meters in altitude that we lost when we first left Zermatt. But we've got hundreds of meters more to climb, and now we're surrounded by serious snow and ice. This is avalanche country. The only way to stay safe is to take cover, and on this route, that means snow sheds and tunnels. Lots of tunnels.
So this is really exciting. We're a couple hours into the journey and we're about to hit one of the most famous spots on the route. It's called the Furka Tunnel. It's 9.5 miles or almost 15 kilometers long. It cost $300 million to build and took a really long time, but it's incredibly important because this tunnel is what allows the Glacier Express to run in the winter. Otherwise, we'd be going over the mountain and through a very avalanche-prone area. Here we go. Now we're in the Furka Tunnel, and we're going to be here for quite a while because it's really, really long.
Meanwhile, even in this tunnel, we're still climbing hundreds of meters. When we finally come out the other end, hey, I could use some sunglasses.
We're just a minute away from one of the most remarkable parts of the journey and easily the most challenging point on the route. And you can tell from all the snow how high up we are. This is the highest we're gonna get.
2,044 meters above sea level. It's the Oberalp Pass, which means, you guessed it, the Oberalps Pass.
We had a rapid ascent of 1,000 meters, and then we hit that highest point on the trip. And now we're engaging in a very rapid descent. This is one of the only trains on Earth that could make this journey. Look at that.
We're heading back downhill again to the town of Decentis. After that stop, we'll keep going down into the lowest point on our route. and the awesome scenery of the Rhine Gorge. The train has to work just as hard on a steep descent as when it's climbing. Not only with the cogwheel, but with the brakes. The worst thing any engineer can imagine is a brake failure. That's why here at the Landwasser maintenance yards near the Swiss-Austrian border, every new Glacier Express locomotive gets extensive brake testing.
So now you can see how the brake force is increasing. This is the pressure and this is the kilonewton. So we have 9.5 kilonewton in brake force by a pressure of 1.93 bar.
David Vigratz is an expert on operational testing of brakes for trains like the Glacier Express.
If you have a train that is not braking, well, anything can happen, okay? So the brakes are the first thing that we're testing.
David oversees a series of brake tests on this brand new Stadler Rail locomotive. It's a highly controlled and computerized process.
We do brake tests with different speeds and always pulling the emergency brake. And then we check out the brake distance and the curve of the deceleration.
This time, David notices that something's up.
It's called 1.5. This deceleration.
On one coach, the anti-skid brake system has kicked in briefly. It's supposed to help keep the wheels from skidding when braking on a slippery surface.
Yeah, there's one curve here, and that makes no sense because of the rest of the train is not skidding at all, so there must be something wrong at this coach that we have to check.
David repeats the test at 100 kilometers an hour. That's as fast as the Glacier Express is ever likely to go.
This time everything is just fine. No gliding, no anti-brake system, the deceleration, everything is okay.
By the time David's done checking out these brakes, they'll be a model of Swiss precision. Back on the Glacier Express, next to the locomotive driver, no one is more aware of the brakes than Alexandra and her kitchen staff. For them, steady brakes are critical, especially during moments like these, serving hot drinks or wielding a sharp knife. Now that we're losing altitude again, I chat up some of my fellow travelers about how they like the trip so far.
We thought we did great mountains, but coming here, they're astounding, really.
Yeah, we were just struck by the beauty of this country. It's quite remarkable.
What's been your favorite part, Blake?
I think when we hit the glacier field or wherever it was, and just how bright it was.
But nobody appreciates that top of the Alps view like the couple I meet from Thailand, who found the mountaintop a moving experience.
Was that you who cried?
No, actually he.
He cried and he's saying it's someone else.
Yeah, because it's actually me, yeah.
That's okay, I kind of welled up too.
We're entering the town of DeSantis, roughly the halfway point in our journey. This is more than a pit stop. This is where we swap out our cogwheel locomotive for a standard engine. The Glacier Express is co-owned and operated by two separate companies. They use different locomotives because the railroad is designed differently from DeSantis onward. I'm watching the cogwheel locomotive that got me safely through the mountains this far roll away. We're about to tackle the second half of this mountainous train journey using a completely different technology. After gliding down into the town of DeSantis, the midpoint on the Glacier Express's journey, It's time for a big change-up. The rack and pinion locomotive that got us this far has been unhooked, and a standard locomotive, sometimes called an adhesion locomotive, is hooked up in its place. This engine will be heading into mountains as steep as the ones behind us, but it will not be able to climb those tough 12% grades. From here on, the track has been designed differently, so it never exceeds 4%. I'm about to find out that there's more than one way for a train to conquer the Alps. John Capri's is an engineer on the Glacier Express. But he's more than that. He's also a local train historian who put himself in the shoes of the original surveyors who designed this half of the track a century ago. They studied the landscape and figured out where and how to lay the rails to keep the grade under 4%, no matter how steep the mountains. John joins me on board and reveals how they did it, starting with something called an open loop.
The open loop is built to gain altitude because the valley is steeper than the train can climb. So there is this open field that is wide enough for the train to go one way, then around in a short tunnel, turn 180 degrees, go back a little higher, the other way, turn a second time, you'll be on your original direction, but much higher up.
Open loops of track that snake back and forth as they climb or descend a slope might be 3 times the length of a direct route you could take if you had a cogwheel.
This is not easy.
So it's doubling back on itself, but
Yes.
it keeps gaining altitude with each different pass.
Yes, it's a very ingenious way of gaining altitude without spending too much money on tunnels.
Taking us on these open loops is a new engineer. Before becoming a driver on this eastern part of the Glacier Express route, Oscar Schwartz was a commercial airline pilot for 17 years. When faced with a job relocation to Asia, he opted for a career change instead.
Since my heart is really here, I love the mountains, I love this area, I decided, no, I don't want to go to Asia. And so I got the chance to change and start driving a train.
Oscar's switch from planes to trains brought new and surprising challenges.
In the airplane, you have high peaks, like a takeoff and a landing. And afterwards, during the cruise, the pilot has more relaxing time during the day than being a train driver. There you're always busy, you have always to do something. I cannot just lean back and enjoy.
That's because enjoyment is reserved for the passengers, topped up with a hearty lunch. And together with the high-end service, I get a great view of the lowest point on the route, only about 600 meters above sea level. It was formed by landslides that happened during the last ice age.
So this is really cool. The massive cliff faces all around us are actually the walls of the Rhine Gorge. We're in the middle of the gorge right now. That's the Rhine River, and this area is referred to as the Grand Canyon of Switzerland. And you can see why, it's absolutely beautiful.
The trouble is, here we are in a deep gorge, and we have to climb about 1,200 meters to get out of it, or we'll never reach St. Moritz. But how? Up ahead, it will be impossible to make giant open loops back and forth across mountainsides.
Higher up, the valley is so rocky and so narrow and so dangerous because of avalanches that you can't loop around in the open.
How avalanche prone is this area?
Very dangerous. This is an avalanche run across the valley.
Here?
Right over there. You see this area? The avalanches come down there every spring. And the line could have been built there, of course. It's open meadow. It would have been cheaper to build, but it would have been destroyed every spring.
Right.
Tunnels can protect the train from landslides and avalanches, but it turns out tunnels can also help the train gain or lose altitude. They're called spiral tunnels.
You have to turn inside the tunnel like a corkscrew. You make a 360-degree turn inside the mountains and exit up there.
The train comes out directly above the spot where it entered, only higher up.
So we're about to go into the mountain, we'll do some spirals, and we'll come
Yes.
out up there. Here we go.
You come out more or less exactly above where you entered, just a few meters higher up. So it's the last resort if you have no space and you absolutely need to gain altitude to build 1, 2, or even 3 spiral tunnels, as has happened here.
And so when we've gone through all 3 of these spiral tunnels, how much elevation will we have gained?
Well, we'll be up at almost 1,800 meters of altitude.
Wow.
All this twisting and turning is made easier because the distance between the wheels on the Glacier Express is so narrow, only 1 meter wide. That's almost 1/3 narrower than on ordinary passenger trains. This narrow gauge is custom designed for tighter turns in loops and spirals, and smaller tunnel dimensions. What I find cool is how often this mountain climbing train avoids traveling into and out of deep gorges by taking a bridge between 2 high cliffs. They're called viaducts. There are almost 300 of them along the Glacier Express route, and the most amazing one on the whole line is coming up now.
That is the Landwasser Viaduct. It's the most famous of the hundreds of viaducts on the Glacier Express route. And it is awe-inspiring. Wow.
I wonder what it's like driving the train over it day after day.
Yeah, it's a little bit strange because you have the impression there is nothing and it's very narrow, so it's a little bit something you have to get used to it.
It is a masterpiece of engineering. Built in 1901, it's 65 meters high, 136 meters long, and made entirely from local stone. It's still standing after all these years, and John just can't resist showing it off.
It's like a church spire. It's very, very tall and narrow. It is an icon. There are millions of photographs showing it, and it has something that has developed its own life because everybody looks at it.
And at the base of the viaduct, a UNESCO World Heritage Site plaque. John headed up the committee that lobbied hard for the designation. He was inspired by the profound connection that the original builders had with the Swiss landscape.
So the engineers had to know very much about floods, about avalanches, and they had to know a lot about nature to build this line as safe as it is.
Safety was a priority for this railway right from the beginning. But there is one growing concern that faces the Glacier Express today, and we're about to drive right into it. We're heading toward the oldest tunnel on our journey, with a disturbing reminder that just because it's carved in stone doesn't mean it lasts forever. We're nearing the last hour of our Swiss Alps train trek and approaching the second longest tunnel on the Glacier Express line.
So now we go through the Albula tunnel. It's 5 kilometers about long.
The Albula tunnel was the first tunnel ever built on the line. It took 5 years to complete and opened to train traffic in 1903. But unlike other tunnels along this route, it's now really showing its age. It's midnight, when the trains aren't running, and the safest time for structural engineer Gilbert Zimmerman to closely inspect what it is that keeps him awake at night.
One problem is here the cement. It's so old, it's not stable enough to keep the bricks together. The other problem is that the water, which we can hear right now, builds up a pressure behind the rock and the wall. This pressure might push the wall into the tunnel, and who cover the tracks.
The mountains of the Swiss Alps aren't all made of the same stuff. Some of the rock the Albula Tunnel cuts through is limestone, and limestone is naturally soft and layered, and the layers can be porous. Combine that with a high glacial runoff through the cracks of every snow-capped mountain, and you've got very leaky walls. That's why now, after 112 years, the walls of the tunnel are crumbling. The water seeping through the rock is getting out of hand, sometimes gushing up to 300 liters a second. There's also a glacial lake on top of the mountain above the tunnel. That means more water seeping downward and huge pressure on old infrastructure.
It could be a catastrophe when this water pressure is too high.
The tunnel needs its own ditches and pumping system, working 24/7 to divert the overflow and keep the tunnel from flooding. The safest solution is to build a better tunnel, and Gilbert is the lead engineer.
We are standing in front of the new Albula Tunnel 2, which we started building in, last year in August.
The construction of the new Albula Tunnel has begun, right beside and running parallel to the old one. It's an ambitious €345 million project.
As you see here, we are some meters already inside. Today we are about 200 meters in 84.
Like most of the 91 tunnels along the Glacier Express route, the old Albula Tunnel was dug with simple tools and backbreaking labor. It has the most tragic history in the entire line's construction, with over 2,000 accidents and a horrific cave-in and flood that caused 16 railway workers' deaths. But the geology of the mountain is better understood today, and Gilbert's crew has got a brilliant new strategy. In this vault-like setting, workers are jamming 60-meter pipes into the rock face in the shape of an arc. The pipes are filled with salt water, then frozen slowly to a very low temperature. The pipes get so cold that the surrounding rock also freezes, creating a solid arch. Crews can then excavate inside that icy canopy to build the new tunnel. The canopy is temporary, and after a section of tunnel is safely hollowed out, the walls are supported and sealed with concrete, and the ice eventually melts.
We solved the problem on a basic idea. In this way, we are going through like in a shell.
The rock freezing technique is slow. They inch along, freezing large sections at a time over 4 months before excavating them.
The next step will be we open the rock again with the heavy machines.
And what a difference a century makes. No hand tools here, just very large, incredibly wicked machinery instead.
Before we had 1,300 people each day on this work site. Today we have 5 people at the front work, and on the whole work site about 8 people.
The new tunnel will take 8 years to complete. This new excavating method is much safer, but it's also slower, especially going through limestone.
When the rock is harder, we can open up to 9 meters a day. But this is a really bad rock, so that's why we have only 1 meter or 2 meters.
And Gilbert knows that every meter excavated brings his crew closer to the most dangerous part of the mountain. It's an old fault line. It's unstable, and there's no way around it. I'm nearing the end of my incredible Glacier Express train journey through the Swiss Alps. This is the Albula Tunnel, the oldest train tunnel on the Glacier Express route. and it's being replaced. But foreman Gilbert Zimmerman knows that the construction of a new tunnel comes with an extraordinary danger. Running through the center of the mountain, there's a fault zone of unstable rubble. It's the scar of an ancient earthquake.
So it's like crushed rock, crushed into little pieces like this, filled with water, sand, and mud.
It was discovered the hard way during the construction of the first tunnel, when the walls collapsed.
I was completely flooded with mud. Stones like this, working was stopped for over a year.
There's no way for Gilbert to avoid this fault zone. They'll have to dig through it. History's proven how risky that is.
The risk that we have the same accident as 100 years ago. This area will be flooded and the whole water system above the surface will collapse. Maybe we could empty the lake, which is right now above us.
But their ingenious rock freezing technique promises safer tunneling for workers, and someday a safer tunnel for trains and passengers.
We also have much more security and safety in the new tunnel. The old tunnel we converted into a security tunnel after we have the new tunnel in operation mode. Between these both tunnels we have 12 escape routes which people can escape in case of an accident with a train.
All of this Albula Tunnel drama is happening right on the doorstep of the nearby mountain town of Preda. So protecting the environment is critical. But the cleanup is no small job. They've got to get rid of all of that excavated rock that's coming out of the new tunnel. 250,000 cubic meters of rubble. Crushed rock is removed on massive conveyor belts, a whole network of them running through the system like big yellow drainage pipes and carrying it off. That means no noisy dump trucks and minimal damage to the landscape. The crushed rock is converted to concrete and used to reinforce the tunnel walls. And the runoff water is purified and returned to nearby streams. For now, the old Albula Tunnel remains in use, constantly monitored and repaired, until the new tunnel is completed in 2023.
I have to wait now till the other train from the other side enters the station, and then I will get the green signal. Now it's green, open.
Finally, out on the far side of the Albula Tunnel, as the Glacier Express approaches its final destination, St. Moritz. I'm thinking, sure, this might be one of the most exclusive holiday destinations in the world, but the journey getting here is an exhilarating end in itself. From the mighty Matterhorn to the Rhone Valley, from the Furka Tunnel to the Oberalp Pass, the Rhine Gorge and the Landwasser Viaduct. Wow. I can't believe how much spectacular geography this train fits into one 8-hour shift. If there's anyone I've met who really loves this train, it's John. When he was asked by the UNESCO people to put together a historical record of the line, he walked the entire eastern half, from Descentis to St. Moritz, imagining what it was like to lay those tracks.
And I walked through all of those tracks, over and under all these bridges.
A labor of love that convinced UNESCO to grant World Heritage status.
Well, I can say that I think this is one of the high points of my life.
And riding the Glacier Express is a high point of my life, too, in more ways than one. And here's St. Moritz, the birthplace of downhill skiing and the end of the line.
Wow, what a spectacular journey. I've got a whole new appreciation for Swiss engineering, all of the challenges that had to be overcome to create this route in the first place. And I can see why people come from all over the world to take this journey. What a ride.